Hey, good morning. My name is Carsten Tieteler. I'm a SAP Infrastructure Solution Architect, and I'm happy to present now today at SUSECON 2020 about what you have to think about, critical steps for archiving high performance in your SAP S/4HANA enterprise landscape. I'm working for IBM, as I already mentioned, and I have here the agenda for today's call. I will do a short introduction of IBM Power Technology and a market view, how we are doing in the SAP HANA space. Then I will tell you about how we work together with SUSE in the high availability area, what we have already reached there, how we set it up. Then I will talk about very important how to connect SAN or network attached storage best practices to get really high performance out of your installation. The same is for backup restore, probably for snapshots. Then I will provide you some information how you really can leverage our technology to really restart very fast the HANA system with virtual persistent memory. And afterwards, I will talk about SUSE Live Patching, which is a tool from SUSE, which can really help your applications up and running very in the time when you have to patch the kernel. So HANA Power was getting on the market 2015 in August, September timeframe. I will say not very late, but much later than it was introduced as appliance in 2011. But as you can see here in the slide, we get a lot of market share in 3-4 years. We get a big award from SAP themselves with the Pinnacle Award in the year 2018 as the SAP Global Infrastructure Partner of the Year. We have more than 2,500 clients, and we get in the meantime very much attendance from MSPs, cloud service provider, which they are also using IBM Power for their HANA installations. In the majority, we have as well at the beginning a lot of customers who were going back from x86 installations back to Power because the traditional SAP is as well running on Power, so they harmonized as well their installations. On the next slide, you see here a short overview of our product portfolio from the Power servers. You see on the left side that we have scale-out servers, which are 2-socket servers with at most 24 cores and up to 4 terabyte. Then you see an enterprise server which has a 4-socket and 16 terabyte. On the right side, you see our scaling really enterprise machine, the E980, which is in the best 192 core, 16 socket with 64 terabyte. So a very high scalable machine where you can install a lot of HANA instances. To get you now a little bit to the point, here are some highlights which we already have reached in the SAP HANA space. You see it here, we have the largest HANA BW scale-up installation with 24 terabyte. The same is also available for S/4HANA, for Business Suite installations up to 24 terabyte. For both kind of workloads, we have as well scale-out solutions in place. We have, and we are very proud of that, we have up to 16 productive virtual machines on a server. We call that as well LPARS, where we can host on one server 16 productive SAP HANA installations. And that is in combination with our PowerVM virtualization engines. I already said you about Pinnacle Awards, but I also want to give you the point that we have some really good customers, reference customers. They see as well that the costs, when you can leverage the Power virtualization and the Power technology, that you can as well drop your costs for your installations. Here you see a typical picture how we set it up, a typical server with different workloads, with IBM I workload, with AX workload, probably application servers, and with many HANA systems with quality assurance, dev, probably sandbox systems, and as well production system. You see here we started very early, and we started when we started with HANA on Power, we started with SUSE 11, which was a big engine implementation, but with the introduction of HANA 2.0 and SUSE 12, we started in a little engine installation, which is the same as x86, and you see here we are since there certified for every release, for every new service pack which is SUSE providing. I just want to mention it as well. Red Hat is a possibility to install it on Power. We have the same functionality for all different Linux derivatives, but we have much more installations on SUSE than on Red Hat. We started with SUSE, and you see here all the virtualization stuff was really developed with SUSE, and we have the possibility to install our workloads in shared processor pools, which is the most seen installation in the field. But as well, we have some dedicated donating LPARS, which was at the beginning mandatory to set it up when you had SAP HANA on Power Systems, to do it in dedicated donating. That means the cores were really dedicated for this LPAR. In the dedicated donating setup, the not used LPARs, not used cores were going back to the shared processor pools. And that is the virtualization. So our traditional SAP workload and other workloads, web servers or whatever you have installed in your data center, runs normally in the shared processor pool. That means the different workloads have a profile for the LPARS, and they get the resources which they need. When they don't use it, the resources are in the shared pool. And this technology gets now even more available for SAP HANA on Power Systems. We have a little restriction right now that we can only use one so-called sub-NUMA node, which is one socket. That means we can maximal scale in such an installation to 6 to 12 cores and max to 4 terabyte. But I think that's the most of the installation in the field are between 1 and 4 terabytes. So that is sufficient for the most installation, and you can use as well shared processor pools for HANA deployments, for production HANA deployments as well in the field. This is supported on Power 9 and Power 8 systems. So yeah, that is how IBM Power customers normally set up their systems in shared processor pool LPARS, and you can use that now as well for SAP HANA. Coming now after the technology preview or introduction to how we do high availability. SUSE provides with SLES for SAP as well the high availability extension for their SUSE Linux enterprise server, and you have different possibilities to set high availability clusters up and running. Very important for very critical systems where we need probably the performance optimized method, where we have active customer cluster, and we are using HANA System Replication to replicate the data between system 1 or data center 1 to data center 2, to have the data already in memory and to really just change the IP addresses and be up and running very, very fast. On the other side, you can do a cost optimized installation where you use the required or where you use the resources on the second data center for other systems like quality assurance sandboxes. Even when you have a chain topology where you have more, probably for DR installation, where you have on one data center your production, on the other data center your high availability installation. You have probably a third installation where you have your DR location when the first two locations will fail. As well, that is possible, and even with scale out, as I mentioned before, you can do high availability setups, and they are the same like on x86 platform. So it works with a pacemaker cluster. You can configure active, passive, whatever you want, and that is as well available for NetWeaver cluster and as well for SAP HANA HEC Replication Server, which is as well a single point of failure in such an installation, not only the HANA database, as well the application part. And I have here provided you links to SUSE, where they have really the best practices how to set up HANA system replication in scale up or in scale out topology, or even how you set up two high availability clusters when you also want to protect your application. That means the HEC replication server setup. HANA, and you know that already, is in-memory database where all the calculations, the data is in memory. But even for persistence, the data, because at the beginning you have to restart when you have to patch a HANA database, or you have to patch the operating system, or you have to install a firmware on the hardware, you need a persistent layer where you really, when you start from scratch, load the data in the memory. And you see HANA is as well working as a database, is providing logs. They have to be collect all the updates and deletes and inserts for the database, and that means all the changes and as well the save points where we save the changed data in the memory back to disk. Even when we, and that is special for data for HANA, when we have the data merge process where the two different delta stores in the HANA database are merged to one. That is as well a I/O intensive process as well. Writing the logs, they must be written very, very fast with low latency to the disks. When we have save points, that's a bigger amount of data, but we need a big throughput in that case when we save the save points. Or think about when you save your data from local storage to the backup storage. You can do it in a SAN attached environment, but when you do it in a network attached environment, you need a high bandwidth as well for that. When you think about that you have patched or you had a problem, you have to restart. Then you have, as I said before, you have to load up your data from disk back to the memory of the server. And that is as well very I/O intensive with high bandwidth process, which needs a good or a very good infrastructure in a SAN or in a network attached storage environment. From IBM perspective, we have a huge storage portfolio, and as one big sentence, all IBM storage systems are certified for use with SAP HANA. It can be, as you see it on the left side, a network attached storage solution with Elastic Storage Server. It can be our flash systems in different approaches or in different models. It can be virtualized with our SVC, SAN volume controller, or Spectrum virtualized as it is meant now in the newer times. Or you can use as well high-end storage systems which are in the most times seen for our System C systems, but as well are available for open systems, the DS8000 machines. To round up the complete portfolio as well, for data protection and cyber resiliency, we have tape devices and as well software to really protect the data. And so, as I said, our complete portfolio, we have NAS or network attached storage, we have SAN attached storage. You can use that in our best practices approaches, and all is certified. And even when we are thinking about the differentiations, we have different models where we see a combination of SSDs and HDDs. That means that are TCO optimized systems. You see on the other side only NVMe or SSD systems where we have the best performance. Then we see a clear roadmap where we provide storage class memory and easy tiering to leverage again the performance at a better TCO. That means we are looking at the data, and when the data is warm or cold, we do it easy tiering, lowering to other cheaper devices. In our flash systems, we have our really own developed flash core modules which has a much greater endurance than industry modules. We have embedded hardware compression, and we have as well, and that is very, very important, high availability solutions as well in the storage systems with HyperSwap or with SVC, IBM Spectrum Virtualized Stretch Cluster. To complement this, we have IBM Storage Insights to manage and get the right information from your storage devices, and as I already mentioned, the necessary components to protect your data. Here you see, and that is a joint project from SUSE with IBM, with SAP and their SAP HANA Enterprise Cloud, where we integrated network attached storage from NetApp to our Power servers and provided the best possible architecture, the best possible performance to provide really high performance, high scalable, high available architecture for that. You see at the bottom the links where we have made a joint best practices document with NetApp. It's also available, all the information which I provided you before with SAN attached storage in our best practices tech docs, where you really see how to set it up, how you have to really define and configure the ADISCs, the log file systems, the HANA file systems, and all that stuff. Coming now to backup restore, as I said as well, this is a very I/O intensive process. When you have to back up your reader logs, your log files from your HANA database, you have to protect your data, and you have to really transfer the data to, we call that Tivoli Storage Manager, or IBM's Protect server. You can do it over network. You have not to do it first to backup to disk and then to the server. You can directly stream it to the server. It's SAP compliant certified. It's controlled by SAP. But what we see now when we really talk about high performance infrastructure solutions for SAP HANA, that is that the clients are doing snapshots for the HANA databases with software solutions. Our software solution is called IBM's Protect Spectrum Copy Data Management, which really provides, and you see that on the left side, space efficient snapshots on the local side. It quizzes the application shortly, then providing a storage snapshot before it's unquizing the database. That's completely controlled from IBM Copy Data Management software. And even you can, for doing probably HR or DR solutions, you can replicate these snapshots as well to other location. So it's an instantly solution, and as well, when you can do the backup, you can do as well a restore and recovery from such a snapshot. That we see in really high performance, high available, critical SAP HANA systems, S4 systems, that they use the snapshot technology to provide or to secure their data. Virtual persistent memory is a solution which we provide on IBM Power Systems, where we really persistent data in our DRAM modules. With that new technology, you have really the possibility and the big advantage to restart SAP HANA database in a case of a planned or unplanned downtime very, very fast, because the main region, and that is the data where most of the column data is stored in, is not so frequently changed. So it's really suitable to put the data on persistent memory, and that data is already available, and that makes the most part of your data HANA database. This technology is available on Power 9 systems with PowerVM, so we integrated that as well in our virtualization engine. No additional cost, because we use the same DRAM modules as you use for the working memory or the row store or the delta region, which is the other part of the HANA database. We use the same technology. With that, when you use the same technology, you have no performance degradation or no latency degradation, and this is available since last year, and it's configured our per LPAR and via our HMC. So the requirements you see there below, it was introduced with SUSE 15 SP1. That was the first release, and you have as well use HANA 2.0 SPS 04 revision 45 to provide this functionality as well to high performance, high available HANA system. And I think that's a technology on the Intel platform. It's called Optane. We have it now with virtual persistent memory on the Power platform, and that is really a technology which helps you when you have planned downtimes, because you have to probably do a HANA upgrade and then to restart the HANA database. All the data or the domain data is in persistence, so you don't have to load it from the disk, and that makes it really efficient, that you are really up and running very, very fast. You need for that PowerVM firmware version 940, and as well on the HMC you need to provide the required configuration sheets. You need 940 version, and with that it's available. Very, very nice technology in combination as well with SUSE's Live Patching, another possibility to provide higher uptimes for your application, because you have to maintain your application, not only the OS, you have to maintain the database, you have to maintain the application, and Live Patching from SUSE provides you really the installation of kernel bug fixes which acquire security issues or data integrity with no impact and no interruption to the applications. It's as well, as you see it here, available on the different platforms, but on the Power platform it's available with SUSE 12 SP2 onwards, so that is a really long time already available, and we have customers that are using that technology already. In combination with virtual persistent memory, you can really provide the highest available and highest performance installation in the market. Live patching minimizes the number of reboots for a kernel patching. Virtual persistent memory lowers the time to load the data, to reload the data into the memory, because for HANA that is processing all the data has to be in memory. So virtual persistent memory helps you to minimize the reload time. Live patching is working on Power 8 and Power 9. Virtual persistent memory as well is a feature only for Power 9. Additional, and I just want to mention that here we have a tool called Live Partition Mobility. That is sometimes used when you have to really provide a firmware update on a complete physical server. So that means with Live Partition Mobility, you can move applications during online time from one physical server to the other physical server. And in combination with live patching, virtual persistent memory, live partition mobility, you have the tools for a really high performance, always on operational availability. In summary, and I just want to close now with this slide, I want to bring you in short terms what makes IBM Power Systems the best platform for mission-critical SAP HANA workloads. Flexibility. With PowerVM, we can run applications always virtualized. We can run it in shared pooled now. We can scale from very, very small instances to 24 terabyte. We have, I think, and that is known in the market, the best RAS features for reliability, availability, and serviceability. That is what Power Systems stands for. High performance. We have the highest throughput per core and the best core to memory bandwidth, and together with the very good I/O bandwidth with our different technologies, with virtual I/O servers, we can really provide the best performance for S/4HANA installations. And I do not want to mention that indeed, but when you count all together, and it's a mystery that in the market Power System is always expensive. That's not true. Flexibility, performance, RAS features, all that provides a really very good TCO and takes care that your applications are always running with high performance and high availability. So I think now it's time for questions, and I want to close the presentation. Here are my contact information, and you can really contact me via email. I will respond to you. Thank you for attendance, and wish you good day, good evening, wherever you are in the world. Stay safe. Thank you.